Hey, it's Mr. Estrada here. Let's get right to our warm-up. It says if AC is equal to X, CB is equal to 2X, and AB is 15, what is the value of X? Well, we know that AC plus CB is equal to the whole. So that means that X plus 2X is equal to 15, and solving for X, we get X equals 5. So if X is equal to 5, that means the length of segment AC is 5 and the length of segment CB is 10. And that makes sense because 5 plus 10 gives us 15. The second question says, what ratio is AB to BC in? Well, they are in a 5 to 10 ratio. Reduced, that is a 1 to 2 ratio. So the answer to the second question is a 1 to 2 ratio. And then the last question says, how much out of the whole segment is AC? Well, then that would be 5 out of 15. It's 5 out of 15. Whoops, sorry. That should say 5 out of 15. And when we reduce that, we could say it's actually 1/3. So the answer to the first question is X is equal to 5. The answer to the second question is a 1 to 2 ratio, and the answer to the third question is 1/3. Now, I want you to notice something here. Even though they are in a 1 to 2 ratio, I want you to notice that AC comes out to 1/3 out of the whole thing. And that's important. That's going to come in handy later. We could also say, even though it's not asked, we could say that CB would be 2/3 out of the whole segment. And that makes sense. If we just look at the coefficients, AC would be 1 out of the whole thing. So that means it's 1/3. And CB would be 2/3. The coefficient here is 2. So it's 2 out of the whole thing, which is 3. When you add 1 plus 2, you get 3. All right, here are some guidelines that I'm going to be using to help us with our problem later. So you could copy these down or just get the gist of it, but these are going to be my guidelines for the next problem. Okay, so here's our first example. It says directed line segment PT has endpoints whose coordinates are P, -2, 1, and T, 4, 7. Determine the coordinates of point J that divides the segment in the ratio of 2 to 1. So what I got here is a little applet from GeoGebra. And I plotted point P and I plotted point T. As of right now, you could see that point J is in such a way that PJ to JT is in a 1 to 1 ratio, and that makes sense, right? Because you could see here that the distance of PJ is equal to the distance of JT, and that entails that it is a 1 to 1 ratio, PJ to JT. But the question says that they would like me to make point J, or to find the point J, such that the ratio of PJ to JT would be 2 to 1. So I'm just gonna play with this a little bit, just move it around. Here it is in a 2 to 1 ratio, and you could tell that's 2 to 1, right? 5.66 to 2.83. 5.66 is approximately twice 2.83. Some of these numbers are rounded off, so they're not going to be exact. But you could see the point, right, that I'm trying to make here. The point is, find the point J in such a way that will make PJ to JT a 2 to 1 ratio. And some of these questions, they could say put it in a 2 to 1 ratio. They could say put it in a 3 to 1 ratio, 4 to 1 ratio. For our question, it says 2 to 1, and I'm just going to basically show you how that happens. So let's go back to our question. Now, the first thing I want to do is I want to find the multiplying factor. And the way I get that is I'm going to add these two numbers. 2 plus 1 is 3. And then I'm just going to take that first number. That's like the numerator of the ratio, right? 2 to 1 can be written like this. And so I'm going to take the numerator and then just put it on top here. So the multiplying factor is 2/3. Okay, that's the multiplying factor. I'm going to use that multiplying factor to multiply it by the horizontal distance. So here's what I mean. That 4 minus -2, that comes from here and from here. So that is x. We'll call this x1. Call this x2. So it's really 2/3 multiplied by 6. And then I'm going to do the same thing with the vertical distance. So that's going to be 2/3 times 7 minus 1. So again, that's going to be 2/3 times 6. All right, so I have to multiply these out. 2/3 times 6 is actually equal to 4. And 2/3 times 6 is going to be equal to 4. It doesn't always work out that way, but it so happens that way here. Now, take these numbers you just got and add them to the coordinate P. So the coordinate P is -2, 1. So take these numbers you got and add them here. And we're going to get our new coordinate J that way. So 4 take away 2 is 2. And 4 plus 1 is 5. So our new coordinate J is 2.